Is Coulomb's law. We'll have a look at Coulomb's law. Then what is Coulomb's law and who stated it was stated and when? So we'll have a look at that. So as we have discussed about the electrostatic force, electrostatic force is of two types. Electrostatic force is of two types. It can be repulsive. Can be repulsive, and it can be attractive. What does mean by these? So repulsive means like for example, this is the positive charge and this is also a positive charge, so the force between them will be repulsive, means they will be going far away. They will be not coming towards, because we know that same charges always repel each other. They will be not coming closer, they will be going far. So this is what the repulsive force called. And now talking about the attractive force. So for example, this is the positive charge and this is the negative charge. So we know that opposite charges always attract each other. So yeah, they will both applying the force and the force will be attractive, because we know that opposite charge always attract each other. So to find the magnitude or the quantity, like the quantitative amount, to find the magnitude of these charges, magnitude or quantity of these charges, we apply the Coulomb's law. So let's have a look by the example first. Okay, for example, this is a charge and this is a positive charge, and I am taking this is a positive charge. So the charge is always denoted by Q. Let me write Q over here. This is Q1, means the charge 1, and this is the charge number 2. So we know that positive will be always repel each other. Okay, means the like charges always repel each other, means the same charges. So we know that these charges place at a distance. So this is the distance between them, that is represented as R, and they will be applying a force that was represented as F. So this is what the like charge I have drawn. Now let me make the unlike charge. For example, positive. This is also positive. So positive will be coming towards, mean attracting towards each other, and the distance between them will be also known as R, and the force that will be applying each other, that will be considered F. So to find the magnitude of these charges, we says the Coulomb's law is applicable for these. So let us have a look at what the Coulomb's law says. So the Coulomb's law was introduced by a scientist, Coulomb, okay, and he introduced that in 1885 he introduced this law. To find the magnitude or the quantity of these charges, we can find by the Coulomb's law. So if we talk about the statement, that what the statement of the Coulomb's law says. So basically Coulomb's law says that the magnitude of the product of the magnitude of the product of the charges is directly proportional to the force and inversely proportional to the distance between the charges. So we know that there are two types of proportional, directly and inversely. Directly means when we increase the one thing. So another thing will be obviously increase, so that is known as directly relation. And if we talk about the inversely relation, so if we increase in first thing, so the another thing will be obviously decrease. So that is what the directly and inversely relation looks like. So if I write it mathematically, like F is directly proportional to the charges. So we know that there is no sign present, like no plus sign or multiply sign that is called the multiply sign. So when they are present in this form, that will know as the product form. Okay, always. So if we like read by the statement that magnitude of the product of the charges, like you can see, product of the charges is directly proportional to the force. Okay. So if I could explain you this, like for example, this is the charges. Okay, so these are the charges that is directly proportional to F. So if we increase the distance, we increase the distance, so force will be decrease. How? Like if I increase if I increase the distance, so the force between them, these two charges, will be obviously decreased because they are very far away from each other. So if I decreases the distance, so force will be always increased, because you can see if I decrease the distance, so force will be increased. They can repel they can attract each other. So this is what the inversely relation looks like. F is inversely proportional to R. Okay, so this is the equation 1 and this is equation number 2, as you can see. Now if I combine these two equations, so F is directly proportional to Q1 and Q2 and inversely proportional to the distance between the charges. So if I remove the directly sign, obviously, so here the constant will be coming, and that constant is named as Coulomb's constant, and that have a value as well. Okay, so we'll discuss that in another video.